All right, let's jump right into a massive headache for anyone building or using web-based AI: duplicate model downloads. Today, in this explainer, we're unpacking a total game changer called the Cross-Origin Storage API. It is literally going to reshape how our browsers handle massive AI assets, and you're definitely going to want to pay close attention to this.
So here's our roadmap for this explainer. 1. The web AI caching problem. 2. Meet cross-origin storage. 3. Content addressable storage mechanics. 4. Privacy and security safeguards. And 5. Transformers.js pilots the API. Let's start with part 1, the web AI caching problem, and the incredible amount of waste it causes today. Seriously, have you ever wondered why your browser is forced to download the exact same 177 megabyte AI model file every single time you hit up a new web application? I mean, think about it. You visit one site to transcribe a podcast, and you wait for this huge download. Then tomorrow, you go to a completely different, unrelated site for another audio tool, and boom, you're sitting there watching your network tab pull down that identical file all over again. We are talking about wildly popular files here. Stuff like the Whisper Tiny Speech Model, which is around 177 megs, or even the Onyx WebAssembly runtime at 4.7 megs. Right now, these are being completely re-downloaded for every single new domain you visit. The WASM file alone gets requested millions of times. Even if all these different web apps are fetching them from the exact same Hugging Face URL, your browser is just duplicating that network cost and eating up your hard drive space.
Now, you might be thinking, why? Well, the root cause is actually a security feature. Modern browsers isolate their caches by origin using what's called a network isolation key. They had to do this to prevent nasty security leaks, like timing attacks, where a malicious site tries to spy on your browsing history by checking how fast a file loads. So while it is highly secure, it unfortunately guarantees massive redundant downloads for these static, shared AI assets. Which brings us to Section 2, Meet Cross-Origin Storage.
The WCG Cross-Origin Storage API, or just COS for short, is this really exciting proposed browser standard that completely flips the script on how files are identified across different origins. It uses a new navigator.cross-origin storage interface. And the big shift here? Instead of tying a file to the URL it was downloaded from, COS identifies the file strictly by its cryptographic hash. If the contents are byte for byte identical, it knows it's the exact same file, no matter where it was hosted or what site asked for it. By wiping out those redundant downloads, the benefits are just incredible. For returning AI users, you're looking at near instant load times. Plus, it heavily reduces disk bloat, saves a ton of data, and genuinely aligns with web sustainability. I mean, you're lowering device energy consumption and cutting down the carbon footprint just by ensuring a 177 megabyte file is downloaded exactly once.
Let's move to Section 3, Content Addressable Storage Mechanics, to see how this actually works under the hood.
To quote the proposal, COS changes the caching model from origin isolated to content addressable. That is a massive paradigm shift. We are moving away from identifying a file by its web address and instead identifying it by its exact digital fingerprint. It's kind of like the concepts we saw in systems like cache digests for HTTP/2.
So how does the workflow actually play out? It's super efficient. First, when you visit that initial AI app, your browser fetches the file normally from the network. Then, it computes the file's SHA-256 hash. It grabs a file system file handle for that specific hash and saves the blob right into cross-origin storage. From then on, if any other origin requests that exact same hash, the browser serves it up instantly. It just bypasses the network completely.
And my favorite part? You get absolute integrity by default. The browser automatically verifies that SHA-256 hash right when it writes the file. So say a provider updates their model weights without changing the file name, or maybe a sketchy mirror serves up modified bytes, the hash just won't match. The browser immediately throws a not allowed error and slams the door shut. No tampered files, period.
Okay, Section 4, Privacy and Security Safeguards. Because letting any random site probe around for a file's hash creates a huge cross-site tracking risk, right? Let's see how they fix that.
First off, developers have explicit control over visibility using an origins metadata tag when storing the file. If you set this to a wildcard, an asterisk, the file is globally shared, which is perfect for open source Hugging Face models. But let's say you have a proprietary proofreading model used only at your company. You just pass a restricted array of your specific internal URLs. The browser strictly enforces this, so your private assets cannot be probed globally. But what about tracking users through those globally shared files, like knowing you visited a super niche site just because you have a unique file cached? To stop that, the browser acts kind of like an exclusive club bouncer. It's called availability gating. Unless a file hits a specific popularity threshold across several distinct origins, the browser won't even acknowledge it exists. It just hands back a not found error to protect your privacy.
And they take it a step further with a brilliant technique called greasing. That stands for Generate Random Extensions and Sustain Accessibility. Basically, browsers will intentionally throw in a little noise. They'll occasionally return false negatives, telling a site a file isn't there even when it totally is. This completely breaks fingerprinting attempts, forcing the site to fall back to a normal network fetch. Attackers simply cannot trust a not found response.
Moving on to Section 5, Transformers.js pilots the API. Let's see who is putting this technology to use today.
Transformers.js, which is the state-of-the-art machine learning library for the web, is already leading the charge by piloting this API natively. In pull request 1549, they rolled out an experimental COS cache backend. Because they're already tracking raw pointers with the exact SHA-256 hashes of their model files, integrating this was surprisingly seamless. You literally just toggle a single experimental environment variable before you initialize your AI pipeline, and it handles the rest.
0. That is the exact number of network requests you'll need to run a 177 megabyte AI model on a brand new, totally unrelated website, as long as the hash is already in your COS cache. You open the network tab, and there are literally 0 requests for those massive ONNX weights and WebAssembly binaries. Your time to interactive goes from minutes down to just milliseconds.
Now, native browser support is admittedly still a draft proposal at the W3C right now, but you don't have to wait. You can test this zero network magic today. Just install the Polyfill Chrome extension from the Web AI community. Or, if you're a developer, grab the official Vite plugin, Vite plugin-cross-origin-storage. It injects the polyfill straight into your local dev server automatically.
The era of wasting gigabytes of bandwidth and storage on duplicate AI models is finally ending. So, are you ready to test out this extension, flip that flag in your Transformers.js projects, and help build a drastically faster, more sustainable web today? Think about it. If we stop downloading the exact same brains over and over, imagine how fast the web's AI could actually think.